Let's look at the basic principles of the 4- and 2-stroke diesel engine. This is one cylinder of a 4-stroke diesel engine. This model uses what is called direct injection. It's an internal combustion engine with the 5 events common to all internal combustion engines. Let's see how they happen in diesel engines. Unlike the petrol engine, air alone enters the cylinder on the intake stroke. Compression, forcing the air into a small volume. This compression heats the air. At the end of this stroke, diesel engine fuel is injected into the combustion chamber. Ignition, burning the mixture. It's just the heat of the compressed air that ignites the fuel. That's why diesels are called compression ignition engines. Power, where energy released from combustion generates the force to turn the crankshaft. And exhaust, removing leftover gases. This brings the system back to where it began, ready for another cycle. Let's look at the 2-stroke diesel engine. It's an internal combustion engine with the 5 events common to all such engines. First is intake, when a blower forces air alone into the cylinder. Compression, squeezing the air into a small volume. This is when fuel is sprayed into the chamber. Ignition, just as with a 4-stroke diesel engine, the heat of the compressed air ignites the mixture of air and fuel. There is no spark plug. Power, forcing the piston down. Exhaust, removing burned gases. All in just 2 strokes. The whole process is a cycle. Everything is back where it began, ready to run again. Both 4-stroke and 2-stroke diesel engines have passages cast in the head to carry oil for lubrication and water for cooling. The combustion chamber can be formed in the cylinder head or the piston crown. These chambers are different from those in petrol engines. That's because diesel fuel is different from petrol, and so is the way it's ignited. In a petrol engine, fuel already mixed with air enters the cylinder and a spark plug ignites it. That's why petrol engines are called spark ignition engines. In a diesel engine, just air enters the combustion chamber first. It's then highly compressed and its temperature rises. Fuel is injected, it ignites due to the heat of the compressed air. That's why diesels are called compression ignition engines. Injectors are mounted in the cylinder head so that they reach into the combustion chamber. They inject fuel into the chamber in atomized form, in a fine spray. Atomized fuel burns more efficiently than liquid fuel. Different spray patterns are used depending on the shape of the combustion chamber. In a 2-stroke diesel engine, an air pump or blower provides clean incoming air at pressure slightly above that of outgoing exhaust gases. The blower delivers air to an airbox surrounding the cylinder. When the piston uncovers the inlet ports, air enters the cylinder through a number of them around the cylinder walls. This fills the cylinder with fresh air and helps blow out exhaust gases. Removing exhaust gases is called scavenging. Without effective scavenging, diesel engines lose efficiency. How scavenging occurs depends on the design of the cylinder and ports. In this example, the air flows in one direction, towards the top of the cylinder. This is called Uniflow Scavenging. Crossflow Scavenging occurs when air enters on one side of the cylinder and exhaust gases exit on the other side. No valves are used and the airflow is across the cylinder. In loop scavenging, air enters across the top of the piston and flows up in a loop before moving in the direction of the exhaust port. Different diesel engines use different fuels. Fuel can be delivered to the chamber in different ways. Direct injection means fuel is injected directly into the chamber. The cylinder head usually has a flat surface, and the combustion chamber is formed in the piston crown. At top dead centre, there's very little clearance between the cylinder head and the top of the piston. Another method of injecting fuel is indirect injection. Fuel is sprayed into a smaller, separate chamber in the cylinder head. This chamber can have various designs. A glow plug is not a spark plug. It's a small electric heater that preheats the separate chamber as an aid to cold starting. It helps the combustion, which then spreads to the main chamber. Direct injection is usually used for larger diesel engines and two-stroke diesel engines, while indirect injection is usually used for smaller four-stroke diesel engines. The way two-strokes and four-strokes get air is also very different. In a four-stroke diesel, just as in a petrol engine, the inlet and exhaust ports are controlled by valves. But the much higher operating pressures and temperatures in diesel engines put more stress on diesel valves, which are usually larger than those in petrol engines. The intake valve passes only air, so it's cooler than the exhaust valve, which releases all the hot gases after combustion. Valves in the diesel engine are usually parallel to the centre line of the engine. Small four-stroke engines usually have two valves per cylinder, one inlet and one exhaust. This two-stroke diesel engine lets air into the cylinder through inlet ports with no inlet valves, but its exhaust ports do have valves. Four-strokes and two-strokes use the same system to control their valves. The valve is held in place by a valve guide with a spring on its stem. A rocker arm compresses and releases the valve spring so that the valve opens and closes. They don't operate at random. They need a system to control them. Part of that system is the cam. A cam is a lobe on a shaft. It's specially shaped to open the valve, hold it open and let it close. So the cams control the valve action. But what drives the cams? Cams are attached to a camshaft. In many diesels, valves are driven by a pushrod system. The camshaft is mounted in the engine block near the crankshaft and gear driven by the crankshaft. As the camshaft rotates, a cam bears against a cam follower that pushes up a pushrod. The rocker arm pivots and opens the valve. Some small high-speed diesel engines use a camshaft in the cylinder head. This is called an overhead camshaft and it's usually driven from the crankshaft. In most two-stroke diesel engines, the camshaft operates the exhaust valves through rocker arms, and they usually have one camshaft for each bank of cylinders. In both systems, the camshaft keeps the valves working in sequence. In the four-stroke, the valves must open only when the piston is in the correct position. The position of the piston is just as crucial in this two-stroke diesel engine. Its exhaust valve must open and close at the right point in the engine cycle. In one two-stroke engine cycle, the crankshaft makes one revolution. How does this compare with a four-stroke engine cycle? How many revolutions does its crankshaft complete from intake through compression, ignition and power to exhaust? It makes 2 revolutions. In that time, what happens to the valves? They open and close once. So the cams must make just 1 revolution, and if the cams make 1 revolution, so must the camshaft. But in each 4-stroke cycle, the crankshaft rotates completely twice. so the camshaft must rotate at half the speed of the crankshaft. This can be achieved by gears. Take two gears with teeth the same size, one with 40 teeth and the other, the driving gear, with 20. When they mesh, the larger one rotates at half the speed of the smaller one. The gear with twice as many teeth turns at half the speed of the other. These gears turn in opposite directions, and the one with fewer teeth rotates faster. Now let them be separated but linked by a chain. They turn in the same direction, at the same speeds as when they were meshed. If the smaller gear is attached to the crankshaft and the other to the camshaft, how fast will the camshaft turn compared with the crankshaft? It will turn at half the speed, just what the system needs. Everything happens at the right time. The piston leaves top dead center, the crankshaft turns, and the camshaft turns too. The cam acts on the rocker arm. It opens the valve as required. This is a two-stroke diesel engine. How many revolutions does the crankshaft make in one cycle, from intake, compression, ignition, power to exhaust? It makes one revolution. During that revolution, the valve opens and closes once. The camshaft makes one revolution too. Camshaft and crankshaft must rotate at the same speed. The gears must be the same size. The power stroke pushes the piston down. The crankshaft turns, as does the camshaft. The cam acts on the rocker arm, which opens the valve at the right time. The crankshaft is the same on four-stroke diesel engines and two-stroke diesel engines. The shape may appear unusual at first. Why won't a simpler shape do the job? It's all to do with balancing forces. This top is evenly balanced and it spins smoothly. Adding a weight unbalances it. How can it be made to spin properly again? One way is to put an identical weight on the other side. The first weight is balanced by the second weight. It acts as a counterweight. Counterweights can turn up in unusual places. Some systems can't work without them. Crankshaft counterweights keep the rotating components in balance and help the crankshaft turn as smoothly as possible. The crankshaft turns because of the forces transmitted through the connecting rods. It must also be held in place. That's done by bearings. Different kinds of bearings have different designs. They reduce friction and allow free movement. The crankshaft is held in the engine block by main bearings, at points called journals. The crankshaft also needs to be located to stop lateral movement. This is done here by using flanges. Between the connecting rod and the crankshaft are connecting rod bearings. They protect the spinning crankshaft at points called journals. On the rear of the crankshaft of both the four-stroke and two-stroke diesel is a heavy flywheel. It stores energy from the power stroke and gives it to the crankshaft to help it keep turning. In a four-stroke, only one stroke in four delivers power. The energy from this one power stroke has to turn the crankshaft through the other three strokes. Without a flywheel, the crankshaft would slow down and stop. In a two-stroke, the same principle applies, but every second stroke delivers power. A connecting rod links the crankshaft to the piston. Pistons in two- and four-stroke diesel engines can change directions hundreds of times a second and are exposed to extremes of heat and pressure. Modern pistons are made of aluminium alloys. Diesels using direct injection have an almost flat surface on the cylinder head, and almost all of the combustion chamber is in the head of the piston. Engines with indirect injection usually have pistons with a flatter head, and sometimes with small indentations. When the piston is fitted, there must not be too much clearance. It has to seal in the high pressures and temperatures generated by combustion. This is done by piston rings, held in grooves in the side of the piston. The top two rings are compression rings. The lower ring is an oil control ring. It scrapes excess oil off the lower cylinder walls.